Hi, my name is Ryan Lobello from Handel Architects. I was the project architect for the house at Cornell Tech. Here we are on Roosevelt Island and the new Cornell Tech campus. We opened in the fall of 2017. Cornell Tech is a graduate student tech campus, and we're the housing for that project. It's 21 stories of student housing with 2 floors of faculty housing, and then amenity space at the ground floor and up at the 26th floor with some of the best views of Manhattan. And here we are inside a 2-bedroom student unit here at the house at Cornell Tech. And one of the things you'll notice right away is the incredible quiet acoustics in the space. It's ideal. And AZA INT's windows were vital in achieving not only the interior comfort and quality of living in this environment, but also the thermal requirements of passive house. So you have beautiful windows here looking out at beautiful views, and you don't hear any of the traffic, any of the river traffic, any of the noise outside. Perfect for studying. Here we are at the top of the house. This is the amenity floor where the students can come out and hang out. It's also the tallest point on campus, so they have banquets and other events here. But this is a great spot to have a demonstration about this tremendous acoustic quality that the triple glazed windows that AZA INT manufactured for us, how they work in the facade. Right now you can hear the quiet acoustic quality in the space. You can see the bridge directly behind me. There's rush hour traffic there twice a day. Now imagine this is your bedroom. Obviously, you want to shut that noise down. The importance of the design process when you're looking at a skin or the facade is vital in all the work that we do, but it's particularly vital in passive house design, which is what the Cornell Tech, the house, is. You have very strenuous air tightness criteria that you need to fulfill for passive house credentials. You have a lot of thermal insulation as well as minimizing thermal breaks. And so in order to have a comprehensive building, you really need to have a cohesive approach, and it really starts at the facade. And the most important part of the facade are the windows. Those windows, that's where everybody interacts with their environment. And as you can see at Cornell Tech, you're in the middle of Roosevelt Island. You get some of the best views in the entire city. And so it was very important for us to focus on the facade and focus on the windows in the facade. Key players in the design process. In our typical projects, we work with a facade consultant. In this case, we also had a passive house consultant. So we worked with Vidaris as our wall consultant, and then Stephen Winters Associates as our passive house consultant. Those are the key players. We bring them in during the schematic design process, work with them very early on to make sure with these high performance facades that they are working the way that we intend. Another key component in the design process when you're working in the facade, particularly with these high performance buildings, is that you have to work with the contractor very early on in the process. It's vital to get that design assist, the quality control that you need carried through from the design process all the way through construction. So what was great about the Cornell Tech project is that we had a lot of different performance criteria for the project, and that we had to work very early on, and we're talking at the concept phase of the project, to realize the passive house design. So the passive house design is about, I would use a metaphor, it's like having a warm blanket around your building and keeping everybody toasty inside and keeping the warm air inside the building. So the concept of the building actually is derived from the passive house performance criteria. We have a wrap around the building, which is the metal panels with the windows that only breaks in a couple spots. One spot is in the middle of the building where the building breathes. That's where we have condenser porches for the mechanical system, and then the other 2 spots are program driven. One is at the base of the building, at the porch, what we call the porch. It's a big lounge area for the students to use, and you can see how the facade peels away. And then the other area is at the very roof of the building, where we have some of the most spectacular views of Manhattan. Early on in the process, we worked with AZA INT to develop some key details on how the windows are attached to the mega panel system to eliminate those thermal bridges. And these are things that did not exist in the United States, the New York market, when we started this process, that are now becoming more and more commonplace. So as our codes are getting more robust to combat climate change, our building systems and the way that we are constructing facades are also adapting to that higher standard. So a benefit working with AZA INT on this specific project was that very early on they met with us. They came from Italy to here in New York in this studio, probably in this exact room, and we met with them as part of a design assist. So we had some very stringent performance criteria that we had to meet, and we didn't know if we could achieve that in the New York market. They came with a lot of experience to the table to help us achieve those goals. So we met very early on. We adapted some of our design intent to meet their technical requirements, and they adapted some of their responses to meet our design goals on the project. So very early on, it was a great working relationship to realize the great windows. With the house at Cornell Tech, we brought AZA INT on very early in the process. There were a number of people involved. Monadnock Construction was the CM on the project, including and also with Hudson related and Cornell Tech as the owners. So very early on in the process, the owners, the architects, and the CM knew that this facade was vital for us to achieve Passive House certification. And so we, very early on, had a window bid package. We were in the middle of DD, design development at the time, and then at that point, we started working on design assist. AZA INT came on board. They smoothed out some of the question marks that we had, and the project really developed and was achieved from that point. We received a lot of support from AZA INT during the process of design and then fabrication and installation on this project. With Passive House, there were a number of things that people in Europe may be used to, but we weren't here. Things like therm modeling, also ISO EN standards. It's a Passive House, it's a German standard, and we were trying to meet that standard here in the United States. A lot of times, the window data that we would receive would be from a typical American company, would be an NFRC or other like local ratings, and we would need that information translated into European standard in order for us to know that we were meeting the Passive House criteria. Well, AZA INT, being a European company with roots here also in the United States, was perfectly settled in to allow us to work through those difficulties and respond, and we responded great. Those windows were better than we initially were asking. It's a performance-based spec, so we come in and we say we would like to achieve a 0.19 U value, and they come in with a 0.18. That's even better. The good windows allowed us to then compensate elsewhere and reduce the amount of insulation, saving the client cost. Some qualities enabling us to achieve these windows in this very high performance facade had to do with window install. And this is the type of thing that on a typical New York project would be built on site. On Cornell Tech, these are mega panels that are prefabricated in 2 locations by Eastern Wall Systems. So what AZA INT would do is they would take the Schuko frames and the interpane glass, and they would make the window. They'd ship those windows then to Eastern, and then those windows would be installed in a factory in Long Island or in York, Pennsylvania. And in those factory conditions, the quality control that you get is much better than what you can achieve on site in a building. And so when you have that level of quality control and you have the importance of the performance criteria of Passive House, what AZA was able to do for us really allowed us to meet our Passive House certification criteria. So during the design phase, there were a number of things that we worked together with AZA INT to achieve on the project. And I don't like to think of these strict numbers that we had to meet. It's a performance-based spec when you're working with Passive House. So like a frame U value, say that a frame is difficult to meet a certain U value, but then you can compensate by having better performing glass or vice versa, or have more insulation in your facade and simplify a detail between the window joint and the facade connection. At those spots, AZA's experience really helped us like fine-tune the performance spec. And so we were able to have a decent SHGC, that's the solar heat gain coefficient, so that in the wintertime in Passive House, we're actually harnessing the solar energy, and so we don't have to use so much energy to heat the space. We have very well air-sealed connections. The windows are gasketed so well and manufactured put together so well that we are able to meet a very high level of air tightness in the facade, which is a requirement of the Passive House criteria. And so what that enables us to do is that the energy that we spend to heat or cool the space stays inside the building. It's not leaking out through the windows. A lot of windows in New York, they leak like sieves. And here in the Passive House building, when that window is shut, the air does not get out there. Of course, if it's a nice day in fall and you want to open your window, you can do that too. But the system in the wintertime, when you're heating, or also on a very hot day in the middle of July when you have humidity up above 90%, and you're trying to cool your space, it's the same concept. You have such an airtight envelope, and the windows are tied into the facade so well that you're not leaking energy out of the building. During the design assist, we worked with AZA INT, and their American counterparts, which were Walsh. Walsh was the installer, AZA INT was the manufacturer. And so those two worked together very closely. And we had both parties in. We had Andrea and Matteo coming in from Italy. We had Danielle coming in from Long Island from the Walsh side. And all together, everybody had to figure out these details. And so you have American union ideas and kind of brushing up against these European kind of finesse ideas about construction, and we had to make it work. And I think that partnership between AZA INT and Walsh was a key factor in making sure that our windows performed correctly. The facade system is so vital to Passive House construction. And working with AZA INT for the windows, Eastern with the panels, we had to make sure that we met these really strict performance criteria. But as architects and designers, we kind of get tunnel vision sometimes, and we can't forget what is the purpose of all these really stringent performance criteria. And it's about the people. It's about the residents who are using the building. And so you end up getting superior air quality, air tightness, and you're not getting pollution from the outside trickling in to the space. You're getting superior energy use. You're not spending extra energy to heat the outside. Like my mom would always say, shut the shut the door when you go outside. This is the same type of thing. You keep everything buttoned up and tight, and you end up saving money, saving energy. But there are a couple other things that are also very interesting that I don't think I realized when we started the process of construction on this Cornell Tech project. In that these windows, they're so airtight, they're so thermally broken, there's an acoustic quality to the space that is vital because of these windows. And so, when you think of New York, an urban environment, we got a bridge which we're eye level with that has traffic, rush hour commutes, twice a day, traffic constantly at all hours. When those windows are shut, you don't hear a thing. It is amazing, and I think it's down to the high performance of the windows, but it's also dovetailing nicely with this passive house criteria. And it's a way that this high performance passive house facade actually is ideal for urban environments. Not only are you saving energy for the clients, you're saving energy and reducing carbon footprint for the environment, but you're also getting a superior interior product for the people who are living there.